Hi everyone, we are starting chapter 6 today. We're going to start with 0.6 matrix operations. All right, so what is a matrix? A matrix is basically a rectangular array, and it can contain variables or constants, and these variables and constants are arranged in rows and columns. They are also enclosed in brackets. Here you can see an example of what a matrix looks like. Now, you see you've got your rows and you've got your columns. Each value, each entry in a matrix is called an element. All right, so if you look here, this particular matrix has 3 rows, and we call this row 1, row 2, row 3, and it's got 4 columns. Okay, and with the rows and the columns, we can provide the dimensions of the matrix. The dimensions are, if it has m rows and n columns, we say the dimension is m by n. So for example, for this one, if it has 3 rows and 4 columns, the dimensions of this matrix would be 3 by 4. So you say this is a 3 by 4 matrix. Remember, rows always come first, then columns. Now, each element then can be referred to according to its position. So for example, this element is in the 2nd row, 1st column, right? So it occupies the position of 2, 1. Now, if the entire matrix is given the name A, then each entry will be referred to as lowercase a. So in the case of this -1, it's lowercase a 2, 1. We don't do commas. This one is a 3, 2. All right, so let's take a look at this one here. We have this rather large matrix called A. So first it says state the dimensions of A. Well, all right, how many rows do we have? 1, 2, 3, 4 rows, and 1, 2, 3, 4, 5, 6 columns. So this is a 4 by 6. And what is the value of the following elements? So A, 2, 3. So A of the 2nd row, 3rd column, 1, 2, 3. That's this one, it's 0. A, 3, 5, 3, 1, 2, 3, 4, 5. That's that one. A, 4, 6. So 4th row, 6th column. That's the 11. A, 1st row, 2nd column. That's your -3. All right. Now, some matrices have special names. For example, a row matrix is a matrix with 1 row. Looks like this. All right. A column matrix is a matrix with 1 column. Looks like this. So the dimensions of this row matrix are 1 row, 4 columns. It's a 1 by 4. This is a 2 by 1. 2 rows, 1 column. You could also get a square matrix. And a square, the sides are equal, so it has the same number of rows and columns. So this, for example, is a 2 by 2. You could have a 3 by 3. You could have a 10 by 10. You could have an n by n. A zero matrix is a matrix in which every element is 0. So as you can see here, you've got zeros for each and every single entry. It could have any dimensions, but it's a 0 matrix. So for example, you will be told, okay, suppose you have a 3 by 4 0 matrix, right? So you have a matrix that has 3 rows, 4 columns, and all of the numbers inside are 0. Now, an identity matrix, this one is crucial. An identity matrix is a matrix in which every element on, this should say the main diagonal, is 1. All right, so what is the main diagonal? If you start with row 1, column 1, this, and you go down the square matrix, that is the main diagonal. So an identity matrix is a matrix in which every element in the main diagonal is 1 and everything else is a 0. This is the identity matrix. It has got huge implications and uses, as you will see later on in the chapter. All right, let's talk about matrix operations. First, adding and subtracting. You can add or subtract matrices if they have the same dimensions, and this is an all or nothing deal. So for example, if one matrix is a 2 by 4, then the other one has to be a 2 by 4 for you to even consider it. And how does the adding and subtracting work? Well, if they have identical dimensions, then each of the corresponding numbers is added or subtracted. So here you would have first row, first column, first row, first column, the corresponding positions. You just add them. A plus C, A plus C, B plus F, B plus F, C plus G, D plus H. And if you're subtracting, it's the same. All right, so let's do an example here. We have 3 matrices, and we're going to add them. So first we have A plus C, so that's 2, 5, negative 1, 3. Make sure when you're drawing it, when you're writing your matrices, the brackets are square and they're not just bars like this. That's notation reserved for something else. So plus C. Now, this is a 2 by 2. This is a 2 by 1. They don't have the same directions, so this is not possible. I'm sorry, they don't have the same dimensions. Now what about B minus A? This is B minus A. All right, I'm going to get an equal dimension matrix. Now, 10 minus 2 is 8. Negative 2 minus 5, negative 7. Negative 3 minus negative 1, that's negative 3 plus 1. And I ran out of symbols. 16 minus 3, 13. And that's your answer. 8, negative 7, negative 2, 13. All right, what is scalar multiplication? Well, in the world of matrices, there are matrices, and then there are numbers that are just plain old ordinary numbers called scalars. So a scalar is just a constant. And scalar multiplication is when you multiply a matrix by just a constant. And really, it's actually pretty straightforward. All you do is you multiply each element in the matrix by the value of the scalar. So it's massive distribution. You take this, so if you have negative 3 times this matrix, you take the negative 3 and you distribute it to each and every single one. So the product here will be negative 3 times 1, negative 3. Going across the row, negative 3 times 5, negative 15. Second row, 0, 6. Negative 3 times negative 6 is 18. Negative 3 times 4 is negative 12. And there you have it. That's all. Okay. Now, properties of matrix operations. So we know that in the world of normal numbers, that you have to get used to the fact that the realm of the numbers that you've been working with until now is a little bit different than the realm of matrices. It's a different world, it's a different society, and they have different rules. We know that for some things repeat. So we know that, for example, for regular ordinary numbers, we have what we call the commutative property. So 3 plus 5 is equal to 5 plus 3. Well, that translates to matrices. So matrix A plus B is equal to matrix B plus A. Associative property also works, right? So if I'm adding 3 plus 5 plus 7, I can either group them like this, or I can group them like this. Well, that also translates to matrices. Left scalar distributive properties. So for example, if I have two matrices, matrix A plus matrix B, and I have to multiply the whole thing by 3, I distribute to each one. Now, if I have matrix A and matrix B, and I have to multiply by a scalar that's on the left, that's on the right side, I can again distribute. So this is the left and right scalar distributive property. All right, so let's apply this. Let's do this one. We have to do 3 times A minus B. So this is 3 times A like this minus B. Okay, and I can use my order of operations to do the inside of the parentheses first. So I have 3 on the outside times, if I subtract these, 5 minus 1 gives me a 4. Negative 2 minus 0 is negative 2. Negative 1 minus negative 2 is 1. 0 minus 3 is negative 3. 3 plus 1 is 4. 2 minus 6 is negative 4. Oh, sorry. And now when I multiply, I have 12, negative 6, 3, negative 9, 12, negative 12. And there you have it. That's 3A minus B. Now, I could have just as easily distributed and had done 3A minus 3B. So I could have multiplied each of the matrices by 3 first, then subtracted, and have gotten the same exact answer. All right, let's move on to matrix equations. It is possible to solve equations involving matrices using the same rules as in algebra. Whereas in algebra, you're solving for a variable x, here you're also solving for a variable, but that variable represents an actual matrix. So the solution will be a matrix and not just a simple scalar number. So how do we solve matrix equations? First, algebraically solve the equation for x, and then do the operations and get your matrix. Okay, so here, this is the equation I need to solve. So 2x minus a equals b. So in this case, this is my unknown, x. I need to solve this equation for x. However, in the end, x is an unknown matrix. So my answer is going to be a matrix. All right, so let's solve this using simple algebra. So plus a, 2x is equal to b plus a. Remember, 2x. Remember, each of these, the a and the b, they're matrices. Now, when we divide by 2, x is equal to 1/2 b plus a. Okay, so let's do that. X is equal to 1/2 b plus a. Well, what's b? That's b. And I want to put this in a bigger parenthesis, plus a. Okay, so x is 1/2. 5 minus 1, 0 plus 2, -1 plus -1, 4 plus 4, -6 plus 2, 7 plus 3. And now when I distribute the half, my matrix, this is a capital X. X is going to be 1, 1, minus 1, 4, minus 2, 5. There we go, our very first matrix equation. All right, this homework will be done in class next time. So this is from chapter 0. We're going back and tying it in with chapter 6. All right, I will see you guys in class.